Good morning, everyone. It's my pleasure to be the closing act and the host for a couple of our guests that we are bringing on to you today. You know, again, my name is Lance Smith. I am the CEO of Primary Data, and Trace3 asked us to come here to talk about innovation, technology, have a good conversation. I want to try to have some fun this morning, and we're going to talk about a lot of entertaining topics. Some of it will be technology. Some of it will just be what's happening in current events today, maybe looking forward about 10 years. With that, I'd like to introduce a co-founder, an amazing company that actually has been driving technology for a long time. He's an entrepreneur. He's a Segway polo master. He's a ballroom dancer. He's a chief scientist. Please welcome Steve Wozniak, better known as the Woz.
Thanks, Lance.
So welcome, Woz. It's great to have you here this morning, but I got to tell the audience a few things. You're a world traveler. This morning was a big challenge for you. So you like numbers. You know what 5135 is an association with you today?
5135. No, I don't get it.
That's the amount of miles that you traveled in the last 11 hours.
Ooh, I started in Oslo with flights getting canceled and changed and finding alternatives and getting to one city and bags getting lost and refinding them.
Yeah.
Oh yeah, but that's
a serious challenge.
We don't ever go through that when technology trying to get things to work right, do we?
You know, I think about the Amazing Race. You know, you did 3 flights. Got here this morning. It's an important event. I think that you know, our host Trace3. About innovations and evolve, it's just such a perfect fit. It's great to have you here.
All I could think about was how bad it would be to miss an event that I was supposed to be at. And I kept thinking, you know, Lance had a flight. Well, I think the last event we did, his plane got diverted and he had to stay up all night and find a way to get there. And he just got in and the event started.
Isn't that amazing?
I thought, if Lance can do it, why can't I?
You know,
am I younger or older?
I was just reading, like, since the 1950s, do you realize that people still spend the same amount of time traveling, but since then, the speed at which we travel is 5-fold faster?
I never heard that one, but all I can say is ever since 9/11, I hate airports and I love driving.
It's true, you do hold the world's record for the fastest Segway, right?
Yes, when the Segway came out, this is an interesting technology story. It came out with keys that had chips that told it how fast it was allowed to go. So if you gave somebody the slow key, they would only ride slowly on your Segway. And of course, I went online and I got the speed codes and the encryption format, and I played with spreadsheets and got it figured out. And then I designed and built a little microprocessor-controlled key burner that could read one key and then burn out new copies for your Segway with its key code, but any speed you wanted. Because, you know, I'm so safety conscious, I wanted to slow my Segway down. And people are surprised because I've actually taken my Segway 108 miles an hour without a helmet. Yeah. In the back of my car.
That's fantastic.
People usually start walking away from me when they hear that story.
So you and I have been working together for a long time. This is, I think, our second company now, right? In Primary Data, you've joined again as the chief scientist. So we both keep
good to be here. Good to be with you. Yes.
You know, why don't you tell the folks, you know, about you know?
Well, we met with Fusion.io.
That's true.
Fusion.io, what an incredible company for the people that work there, changing the world, you know, of data storage systems. And one of the first people I met was Lance, and I just right away, oh my God, you know, the reason I joined the company was all the smart people.
Yeah, well, you know, the interesting part about Fusion was that, you know, we came up with this idea of taking flash memory, right? We'll probably talk more about this today, and how it actually impacted these different memory tiers, you know, within the architecture. That led us to this idea of Primary Data, of utilizing data virtualization. And again, you ended up joining, you know, the company with, you know, our other co-founders, you know, David Flynn and Rick White. What was some of the sort of the interest level? Why was joining Primary Data of an interest for you?
Well, joining Primary Data was because I respected and enjoyed the people that I'd worked with so much at Fusion.io, and it was largely because of the way they thought and envisioned an architecture that was a correct architecture and very good, efficient, fast, low cost, whereas other people were going the traditional, obvious method. Let's just make a disk out of NAND flash chips. This company thought we'll plug the NAND flash chips into a computer and have software, and we can utilize the chips in better ways. And that's how I always thought with my own designs back at Apple. So especially my disk design. So I thought, oh my gosh, they figured out the correct way to do it, and everybody else just wants to go the easy, obvious, standard way. So I admired that. Yeah.
You know, interestingly enough, it was a challenge to figure out how to get folks to deal with effectively direct attached storage, right? Getting storage back into the server because everyone was working hard to get it centralized, right, in one location. But the benefits of performance was amazing.
Well, but the advantage wasn't performance in terms of MIPS. It wasn't how much data, how much you have to spend per how much gigabytes of data. It was in the transactions that are done at a place like Facebook. What is the cost of each transaction, and how do you minimize it? Where's the minimal cost solution? That's why the Fusion IO solution was so great. It was lower cost than even very low cost hard disks, but the time that they took getting the data in, the processor was basically was underutilized. Only utilized about 10% because the data couldn't come fast enough.
Sure.
And I love the thinking. Yeah, the architectural thinking behind it was always oriented towards the end customer, the data centers, the enterprise, whatever.
So here we are at Evol. You know, one of the things about Trace3 is that they're constantly looking for innovation, right? In startup companies. But the interesting thing about coming up with these clever ideas, it does require a culture. From your point of view, when you see these startups, when you talk to them, when you see this type of innovation, what kind of things do you think make a company successful in innovating?
Most of the time when I hear, well, people, it's often too young people have ideas. Every idea of innovation will do something useful for somebody, but which ones will actually become successful, it's largely a guessing game. It's kind of like a friend of mine recently went and visited a famous author, so famous for 2 or 3 of his books, and when he was there, he saw 50 books on a shelf. There were 50 books that author had written, and he said every one of them, he thought, when he wrote it, was just as good as any other one. You just toss them out, and you don't know which are going to be the ones that make hits. Same thing is true of games, technology products as well. You can have just great products that make so much sense by any reasonable numbers and look, but they just came in the wrong year. People weren't looking for that thing that year, and they're heading off in another direction, and another competition goes around the corner. So it's very hard to predict successfully, you know, which innovations. I like the ones that are so far different, so different than the way you operate and use them than people used them before. I don't like just saying, oh my gosh, we innovated, we used this new technology, a new kind of chip, and we made it 10 times faster. Well, that's good. That's like engineering, but it's not like inventing new things, not inventing.
Right.
So I like the inventing. I like things that are so strikingly different. You say, oh my gosh, I would have never thought of that, or how did they think of that? Those are the sort of things that attract me all the time.
Do you think companies can lose sight of this innovation over time?
Almost every company is worried about that. Almost every company says, how do we innovate so we don't get disrupted? We want to be the disruptor. And my solution is, well, you should have a CDO, Chief Disruption Officer, that is isolated, independent thinking, not under control even of the CEO. Division in another city, far away, think independently and study all the trends that might come in the future, what might disrupt us, and how can we be prepared, or how can we be the disruptor and start some little side projects that might become the future.
Yeah, it's like skunkworks projects, right?
And like skunkworks. But you have to be a large enough company that you can afford a little side project going on. It has to be very kind of like just secretive. They're working on their own, and they're not really responsible to anybody except themselves. And get some really brilliant people there. But for innovation, a lot of companies worry about, we've got to keep turning the crank that brings in the money of our companies. We've got to keep things rolling the way they are, and we've got to have engineers improving things and keeping up with the changes in the market and our competition, and we have to handle it in marketing and sales as well. But the real disruptions, don't come about necessarily that way. It's hard to say, we're going to divert some of our resources to look at it doing a whole things differently and saying, even though we invented this technology and we really understand and we know how to use it, it's really not needed. There may be a different way that's a lot easier, and we don't have to do as much thinking. You don't want to give that up. I've been in companies where the existing company culture gets in the way of evolution and innovation. Hewlett-Packard calculators, handheld scientific calculators, was a good example. The only reason they used what was called reverse Polish notation, a strange type of mathematics known to computer scientists. They thought it makes us powerful. We're using computer science. The only reason they did it was they didn't have enough memory on the chips in those days to program natural mathematical formulas the way we're taught in school. So of course, when Texas Instruments came out with a calculator that used normal mathematics, we laughed at it and said it's a toy. They won't be able to do the complicated calculations because every kid in 7th grade is taught to write equations that way. And actually, it was just an easier improvement where you didn't have to think and manage how you were going to solve the problem like you did on the HP calculators. But nobody saw it. You need a skill. If you taught a skill, you're good at it. You don't want to give it up and say that something else is really better. So you miss things, especially when they're easier. And then you say, oh, what a relief. I don't have to think about this anymore. It's just there and it works. You don't want to give it up when you're in the position of having the skill.
Right, right. Well, let's go down that path of these handheld devices and data mobility. So there are many folks that are in this audience today that who have to manage their IT organization at enterprise or suggest solutions for IT. And you've got this environment of bring your own device, a lot of data mobility. Now, folks, we've been traveling together for many years, and I have to tell you, if you get in line with the Woz, in the security line, get in front of him. Because when he brings out his bags of toys that he plays with, you're going to be waiting. I'm telling you, he's got enough electronics equal to the 10 people that are behind him. Why don't you give the folks an idea of what you carry along day to day? Because I know you're a gadget guy, but a lot of it's very
let's give the background behind this. Why do I carry a lot of electronics and gadgets in my backpack? Well, first of all, I'm not going to put it in checked luggage because that's the thing that gets stolen. The one time I did it, I was actually at a Fusion I/O event in Salt Lake City. I was so tired that night, I didn't think. I had 2 of these new precious iPhones that you couldn't buy. You couldn't get them for 4 months, and I didn't put them in my backpack. I put them in my checked bag. By the time I got to Valencia, Spain, my bag was the only one that didn't arrive. And it came the next day, missing 2 iPhones, no TSA card. They arrested a guy a couple months later, putting bags aside, stealing things when nobody was looking. So I put everything valuable to me, my electronics, my chargers, my adapters, my cables, my battery packs, my sound jams, all that stuff, put it in the backpack. So yeah, it's rather full. But I like to experiment with new technologies. I like to say, what are people developing today? Because that gives you insights as to what people have done good, might even give you thinking about what they might even do in the future that's better in your own judgment of it. And doesn't necessarily lead you to, in the days when I was actually real active as an engineer, I think of ideas and implement them right away. Now I more get to observe them, but that's the fun part of life. If you aren't out there looking for what's new and what's exotic and what's neat. So I carry some Android phones and I carry some iPhones of different sizes, and I have all 4 carriers in the US, Sprint, T-Mobile, AT&T, and Verizon. So I can always compare things, and both in cost and performance and all that, and I always need a lot of backups. And still, I go on a cruise and I get no bandwidth at all. And I'm sitting there fighting, and I've got local SIM cards, and they might work great for 2 hours, and then a big ship with 6,000 passengers comes in the younger type, and all of the cellular goes to nothing. But you learn these things. I like to see the fun things they do on products, and of course, Apple makes important innovations in our life, like Apple Pay. Made it so easy compared to what I used to do with Android phones. For about 3 years, I would buy the one phone you could buy that you could go into 7-Eleven and pay with your phone after you turned on the phone, unlocked the phone, found the app and ran it, and typed in a PIN number for your credit card. Then you could pay. Apple Pay, you just walk up, double-click your watch, and you pay, and it's so easy. Apple does things like that, but I like to sometimes get an Android phone and say, you just wipe your hand across the screen. It takes a screen snapshot. Or when you're taking a selfie, you hold up a hand and it starts the timer. These little things are kind of cute.
Clever, right?
Yeah. I mean, features aren't essential anymore in choosing your platform. Platform choices, I think we're so far along. It's what have I used before? What am I familiar with? What do my friends use? What do people say about this and that? And also, what do I want to feel like? Do I want to feel like a prestigious Apple iPhone user? So a lot of it's psychology.
You just mentioned a number of points. You got a lot of data across a number of devices. Do you make use of the cloud? Do you carry along a hard drive with you? I mean, what do you think about the cloud?
Well, I came from the old school background where you do everything yourself and you have your own hard disk and your own personal computer. And nowadays, on the personal level, we move almost everything kind of winds up going to the cloud and sharing between devices. When you're carrying about seven iPhones and a MacBook Pro computer, and you're trying to keep everything consistent and synchronized with each other, the cloud is a really good solution. But I do a lot of manual backups too, because I don't know. I remember the time I had an iPhone 4 in my car, and I could just push that button and say, "Call Janet," and it would call Janet. And then we came out with Siri. And I'd push the button, I'd say, "Call Janet." And I'd wait, I'd wait, and a message would come up. You're not on the internet. And I was on the internet. Serious computers were busy. So I like local solutions when they work if you can't get to the cloud. I travel so much, I'm often off the cloud. I live in a house that doesn't have broadband. Yes, it takes 7 hours to download an iTunes movie. I'm in the one little part of Silicon Valley that all my life has had a lousy phone company, and the phone company is it's a monopoly source of broadband to me, so I don't get it. And people wonder, about 4 months ago, I drove down 5 minutes from my house is the Apple store in Los Gatos. I drove down at midnight, and I sat till 6:30 in the morning downloading different data and localized maps to my iPhone.
Hooked up to their Wi-Fi.
Yeah, stealing it. Yeah.
Fantastic. Hey, let's sort of switch topics. So, interesting enough, Tracy's been a lot of planning for this event, and one of the things they did on their front of their website was they gave the opportunity for the audience and for other folks to ask the Woz some questions. So we've got a few questions that some of them could be a little bit left field, but try and get some insight on you and in your life and kind of what you've accomplished. The first one is an interesting one. They said, okay, with everything that you know, and everything that you've experienced today, if you were to go into the field of information technology, is there one area of IT that you find interesting that you would take a job on?
Very difficult question. I think I would still be down at the maker end in my starting days and development days when I'm young, but I would also look a lot at probably personalized consumer type products like robots that do tasks for us and machines that kind of think. And I really am glad that we're getting closer and closer. Artificial intelligence, I think, is the big field. Machines that sort of think for themselves and figure out, they don't follow one specific set of instructions, but they're taught to analyze and learn and adapt to the situation. And that applies to everything from self-driving cars to eventually, just even the machines that we talk to in our cell phones. It's just becoming a very strange world. Machines are becoming much more like humans and better helpers to us. So I don't know one particular task I'd be doing. I'd probably still be, maybe I love hardware so much in my life, I'm going to assume I would still be that hardware
The data
lover.
center architecture side.
Yeah.
Yeah.
Architecture, well, one thing is, one principle I came up with in my life that never, ever have I found any way to disagree with it. When I was in high school designing computers on paper, just to learn how to teach myself how to do it, no instructions or anything, I discovered through one computer that came out, the Data General Nova, very different architecture than all the other computers. Architecture of what instructions can do and where data can be stored. It was so different. And it was logical, one long instruction of 16 bits. A couple of the bits meant one of the arguments, another meant another argument, 3 bits meant what operation do you do, another meant do you shift left or right or whatever. And in the end, they all added up to the instructions that a computer needed, but it took about half as many chips to make. So what I came up with was this philosophy: always try to design the architecture based around chips that exist. Then you can just connect wires very simply. And when things are simpler, they're easy to understand. Yes, it takes a lot of brain work to develop that way, but so I think architecture that really is based around the building materials is good. One architect can come out and design a fancy building, if it's a hardware, if it's building architecture, fancy building, and say, we'll just hire the people to make it this way. But a real good architect is broader and knows the building materials and designs things around it's going to be very inexpensive to build and yet be just as good.
All right, fantastic. The next question that we've got is that they wanted you to look back in your career, and whether good or bad, what was some of the most important decisions that you had to make?
Yikes. You know what, in the real highlight, the 10-year period in my career when I was just spewing out designs the way Bob Dylan spewed out songs, I don't recall that being an issue at all. I was so well skilled, and I wasn't skilled because I was really bright. I was, good in math, but I had spent so many hours trying to teach myself these skills and trying to teach and come up with tricks that were better than other humans would think of. I'd spent that my whole life that it became very natural. So I didn't really ever have any in that time frame. I never had projects I started that I couldn't even complete or that failed or I was on the wrong track. Everything was A+ and golden. So it's a very difficult question to be answered because everybody likes to say, here were my failures. Well, my failures were only that I loved building fun things that weren't worth money in companies. But they progressed my brain towards the next project, yeah. And I think that applies to everybody anywhere. If you're working on it, especially if you have a motivation. I taught school for 8 years, and I learned that it's less important the material that I taught, more important that it made it motivating, that the students wanted to learn. And I was lucky that I was outside of the public schools, because the public schools don't have that freedom. They can't go back and make sure you learn something, and I could. And, well, whatever. Let's go on.
All right. The next question is it's about data on the move. So specifically, the question asks about hypermobility and connectivity, especially when you're talking about personal items like the iPhone watch, which I know that you like to use, and then Internet of Things, and it's impacting the data center. In what ways do you see that this deluge of data that's coming through the consumers is impacting the data center?
Yeah, it's hard to say data's on the move. The data is in the data centers. It's not moving. The data that's being presented to you is being assembled and calculated and analyzed in the data centers, and you're just fed the results to look at. So really, our own computers are always out there in the data center doing the work. We've just got viewing displays now, and I credit that a lot to people like Steve Jobs, who grew up with their only understanding of computers was a low-cost computer. It did almost nothing because it was wired through a modem to some big computer somewhere that did things. And it turns out that's what the masses want. You want to relieve yourself. You want things to be virtual and to pop up and just be there as you need them. And it's hard to build it into one device. That kind of the software that's required, the hardware, just it's inexpensive. Today's data mobility, you mentioned earlier, bring your own device. And it's actually, there's always going to be a conflict between bring your own device and we're only going to support one platform, because it's generally easier for the support teams in IT to support one platform. We found that in our schools, but bring your own device is more, I don't know, pleasing to the users. Great, I don't have to use your particular device and learn your particular ways. I can be freer in my own mind. I'm not sort of a slave to you telling me exactly how to do things. So I think we're going to move more and more towards the device and the connection being intuitive, like a human being thinks. The human being being more important than the technology, that I'm not going to have to learn all the structured ways to use my device. Eventually, it's going to become much more natural, just like human speech, or very few content, very little thinking. So.
All right, well, let's look at some of the most successful technology companies out there. What do you think caused their success? Was it the right timing? Was it the right people? Do you think the management team was the right idea, or was it just plain luck?
Well, all those things. We're in Las Vegas. We're in Las Vegas, right?
Just roll the dice and start a company?
Almost everything in life, I always say, would I rather be smart or proficient or have money, or would I rather be lucky? Or have a good scheme at blackjack, or be lucky? I'd rather have the luck, I almost always say. But almost everything that you mentioned, having the right managed team could be a factor of luck. Being at the right time, you can make a great product that has its place. And Apple's done this many times, comes out with a product line that just totally drops and fails. Maybe it was 10 years too early. People are going to be ready for that change at a much later date. Even the movement to the mouse-based computers, you could look at it that way. So I don't know. So what are all the factors? It's hard. You can't guarantee you're going to be successful, as I mentioned before. All you can do is get out there and do your best work. And we always say, oh, the products that nobody expected that are so different, so wildly better than other things, they really do have to come from a bit of secrecy in your environment, and keep working and working to get that great a product, and don't put out the first version that will make money. But unfortunately, most companies just put out the first version that makes money. They don't wait around for the great version of something.
Yeah, I totally agree with that. Let's see, there's been a lot written about Steve Jobs, but I can tell you one thing. Steve said many times that Apple wouldn't have happened without you.
Yeah.
And I think...
Actually, that's true, because our only product that made revenues for the first 10 years was the Apple II, and it existed before Steve Jobs knew it existed.
Oh, really? I didn't know that, actually.
Yeah.
We've seen 2 movies now, about the
they're all
the
wrong.
life it
They're all
does,
wrong.
right?
It shows him taking me to computer clubs, because I'm a bright engineer. My God, I was a hero at the computer club, and I took him to show him what it was all about, and I'd already given my computer designs away to everybody there.
So what are some of the things that you'd like the audience to know about you?
I'm very humble. I'm very polite. I'm very nice. I didn't want to ever run a business, even Apple, because I'm not a sort of person that can fire people and say bad things about people. I just want to be a great engineer. I decided before Apple even I was going to be an engineer for life at a great engineering company, Hewlett-Packard. And engineers mean so much to me, because engineers have to make things that work or they don't work. You have to struggle and struggle. Even today, the digital engineers aren't mathematical like the old analog engineers, but whether you're designing digital logic or you're writing programs, It has to test and it has to work, and you're judged by it. And that's equivalent to truth in my mind. And I always rated truth the highest goal of any human being.
Fantastic. Let's move on to the second half of our hosted meeting. And what I'd like to do is introduce our second guest. I have known this individual for about a year now, and we have had a number of events together. The best way for me to describe him is he's an engineer at heart. He's a cowboy. He's a co-founder of one of the most successful storage companies in the world and an author. Please welcome David Hitz. Good to see you.
Hi, Dave.
Good to see you.
I thought they were going to put him down there.
I told him to bring his own chair.
Hi.
Hi, I am number 8. Who is number 1? I'm microphone number 8. Mic number 8. You know your numbers?
So what's your plan? What are we going to talk about?
Well, we're going to talk
Innovation,
about,
I heard.
We're going to talk about a number of things, right? Innovation is certainly one of them. About technology, let's talk about some of the challenges of new technology, new innovations, and taking it into the enterprise market. I believe that for startups, one of the challenges for them is to convince an enterprise, a mission-critical applications, to take the risk on a technology. What I'd like the two of you to do is think about and tell the audience, go back to when you're putting your first product together, especially you, Dave, as you hit the heart of with storage. What was the challenges and what is the kind of the barriers to entry to get that technology accepted by an enterprise customer?
I learned the best lesson about technology sales from the CIO of Georgia Pacific, the paper company. I went out and, we were getting started, but we've been selling largely to tech companies, to internet startups and people doing chip design, software development, and we were trying to crack into the enterprise. And, a company that makes paper, what's more enterprisey than that? And so I give this guy this presentation, and it was all about how our waffle works, how do we lay out blocks on RAID 4 instead of RAID 5 to be efficient, and all this is why this product is awesome. And this guy, it was in Georgia, and I'm going to get the accent wrong, but this guy just said to me, son, you have to understand that what we do here at Georgia Pacific is we turn logs into toilet paper. And I have not heard you explain to me how your box will help me do that better.
Marketing.
And I thought he was a fucking idiot.
Ouch.
And then I went to another, this was like a bank in the Midwest, and did the same thing because I didn't learn anything the first time, right? So I had blocks, waffle, RAID, pictures of how RAID diagrams go. And at the end, the guy was the head of storage, and his team is lined up on both sides of the table. Me and a sales guy are at the other end of the table, and the team is there. And this guy, the boss of this whole team, says, my strategy is not to hire smart people. And all of his staff on both sides of the table is like nodding. And there's a point to this story, both of these stories. So, like where I come from, smart's a compliment. Like you use that word. I think you meant that as a good thing, right?
No, I have different views of that. What we call intelligence may not be the same as thinking well.
But he was thinking more that smart was like a guy with a little beanie cap with a propeller on top. And what his message to me was, I don't hire those people. I expect my vendors to figure that stuff out. I do not want to know about RAID 4 and waffle blocks and layout and how that stuff works. Do you have anyone in your company who understands the insurance business or the toilet paper business? And that's, I think, one of the biggest challenges of startups. Startups are all excited about their own cool technology. They're not as excited about how does that make a difference for the customer's business. And it's bridging that gap that's the big challenge. If you start selling to tech guys, typically if you're selling to an engineering department at a tech company and they're doing programming, that you can just tell them how the technology works, they'll figure it out. But to crack the enterprise, that you need to start to learn about their business, hire people out of that industry, and
channel
like
partners.
really figure it
Folks
out.
that can help you bring the technology to specific verticals and specific applications.
Or, I mean, it can be an intermediary. That's part of the role of somebody like Trace3. And when you look at the role that Trace3 plays and the interactions they do with VCs, you know, when I was looking at Mark Campbell's talk, a big part of that was we go talk to the VCs to do the filtering on the startups so you don't have to, right? I mean, but somebody's got to do that translation.
So, the Woz, you guys really started focusing on consumer-related products. But then there was many, many attempts to go into enterprise early on. I
Well, no,
remember
we decided when we formed the real Apple II, the second company, we decided that we were going to be market driven. And back then, I was the smart guy. You know, I was the smart guy. But over time, I just realized, you know, especially from people like Steve Jobs, you've got to understand the client. You've got to understand what their needs are and how they will use the product. And they don't want to see all this stuff they don't understand. And when I see startups, I say you should have some bright designers, yes, some smart people, but you should also have some people who want to be businessmen, and more importantly, somebody who does the marketing. And the marketing does not mean you understand the needs of the market. You should always include in a startup, I say, somebody who desperately wants your product for themselves. They will be the clearest thinkers about what it should have in it as features and what it shouldn't have and how it should be implemented. So it's very, very good to have one of those people in advance. This is what I really want, like the guy from Georgia Pacific. Should be on your team. He sort of was.
But, you know, when I look at the end customers and you see the choices that are out there, especially with the sort of wide plethora, the wide spectrum of, let's say, storage types, it's now gotten really crazy. First we had storage in a server, then we took it out of the server, now we're trying to put it back into the server again, and then we're trying to stick it up into the cloud. When you guys take a look at sort of the challenges of storage, how do you see it being impactful? I mean, there's, you know, on your side, there is experience from Fusion IO and having flash go very fast. Dave, on your side, it was making it reliable, making it fast, making it centralized. I mean, these are two separate sort of contexts for the use of storage, trying to put together. What do you guys think of where do you think this technology can help us and where it's going? What did you, Dave?
You want to start?
Well, I think, oh my gosh, the storage, the thing is, the storage is kind of like becoming ubiquitous, but it's hard to look ahead and say, we can envision that bandwidths and performance of disk drives and NAND flash memory are going to be here. When things are especially accelerated on an exponential curve, because when things are based upon the thing that came before it, and the next one is based on the thing that was there, and it'll grow exponentially, you don't see the future. Everything is static for a long time, and then all of a sudden it hits and there's a big change in how things are done. So it's very difficult to actually have that foresight. You can do all the calculations in the world, and it's very difficult to drive your business in a direction that's not going to be here for 5 years. So it takes some real thinkers saying, we want to be prepared, because if we're not, we get disrupted.
Well, NetApp was disrupted because the world was based on block-based storage, and now we've introduced a file system in the storage, right? I mean, that was a challenge, but where do you think that's going to take us, in the future? Is it about ease of use and deployment, or only about performance?
So, when I think about where should you put your data and how do you deal with all of the data, it really comes in two categories. There's data that's not that big and small enough to move around, and you can have it in your phone and you can Dropbox it up to the cloud or Evernote it, and it's just kind of, there's a copy of it everywhere. That is a management challenge. The biggest question there is, where did the copies go? Can I keep track of them? Oh, it was secret. How many people looked at it, right? All of those are management challenges. When you start looking at big chunks of data, that's a whole different question. And that's where cloud gets complicated. For people who were in my smaller talk yesterday, I told this story, but we had a customer who let 9 petabytes accumulate in one of the big hyperscaler clouds, and they decided they wanted it back. And 9 petabytes of data, it took them 3 months to pull that data back out of the cloud at the bandwidths they could afford, and it was $600,000 per month. And so that scale of data, you're not just copying it around. You're not having one in your phone and one. You need to think about, for data like that, you need to plan ahead. Where do I want it to pile up, and how do I think about that? Versus, so that's a fun, like that's physics.
Yeah.
The other one's a management challenge, and you can fix it with software. The piling up challenge and how long would it take to move, those are physics problems and planning ahead problems. That's a fundamentally different style of thinking.
So I like the controversial statements. I want to go back to the cloud. Are you telling me a cloud storage is a bad thing?
No, not at all. You know, here's what I would say about the cloud. The most awesome part of the cloud is the compute. That is the easy, no-brainer, just do your compute out in the cloud. Data's the tricky part. And it's tricky exactly because of this issues of, we did a tech demo of dragging and dropping a chunk of data from Amazon cloud to an Azure cloud, and just literally a drag and drop interface. Apple did it in 1982, and NetApp can do drag and drop in 2015. So we're right, but our drag and drop was between one cloud service provider, Azure, and a different cloud service provider. It was between two different data centers. It was in different data formats. A lot of stuff's going on under the cover. But when you think about that, I mean, on the one hand, it's cool, but if you're a CIO and you're trying to make sure that your data is where you want it to be, and people can drag and drop it from one country to another, from one data center to another, how do you keep track of? I mean, it's scary. It's not, you know, the cloud, here's a silly analogy. If you go to Safeway and you buy bottles of water and drink them, you will never get a surprise drinking water bill. If you've got a house at home and your kid goes out in the backyard and turns a hose on and leaves it on for the month, you could accidentally use 10,000 gallons. Right? That never happens. You never accidentally buy 10,000 gallons of water at Safeway. And that's why the cloud, but I mean, does that mean that plumbing is fundamentally bad?
No, but I think the Woz has a solution. He'll go to your house to use the water and then go back home again.
Like the Wi-Fi, yeah.
Exactly.
You want my address? You can use my Wi-Fi too. You don't have to go to the Apple store.
You may laugh, but I have actually had people offer to let me come to their homes, which I have, and sat there from like midnight till 2 in the morning and got done what would have taken me 24 hours at home.
So I'll tell you all my Wi-Fi password. My Wi-Fi password is my cell phone number. And I love that because I can always remember my cell phone number. And anyone who's in my house, like I don't invite people to my house who don't have my cell phone number. But people driving by outside my house don't know my cell phone number. So it's perfect.
But I still think on your petabytes of data issues and moving them around and all this, we still want to put in all the energy in the IT world to make things as small a manual as possible, understandable by the user. And I don't care where the data is and what format it's in. And that's one thing the cloud does by us.
Is there any innovation in that area that was sort of groundbreaking that either one of you have seen or something that's coming along within this decade?
Fusion I/O, NAND flash memory in the store, in the enterprise, yeah. And that was when it was so expensive. We still hardly saw that because of exponential curves and Moore's law that, oh my gosh, it was going to be, you know, much more affordable than hard disks in a lot of places, yeah.
I think at the time we went from $25 a gigabyte right down to now today is under $1.
Yeah.
That's moved extremely fast. So what kind of innovations, or is there any surprises that you've seen in innovation recently, or do you expect to happen before the end of this decade?
Let me make an analogy. In my personal IT life, so never mind work, never mind company stuff, for me in my personal IT life, the biggest revolution in data storage by far was Dropbox. Right? I mean, the idea that my personal data is so little that all of it can be copied multiple places, it's on every device I have, and I just don't have to worry about it. And the interesting thing, and I'm going to link this into business in a second, when you look,
we're waiting.
When you look at the styles of data, I mean, for me in my home environment, there's 3 categories of data. There's videos, like really big stuff. There's pictures, medium big stuff. And then there's everything else I've ever created in my entire life, PowerPoint, all that other stuff, and it's teeny.
You left out music.
Yeah, music is sort of in the video count, the streaming stuff. And what happened with Dropbox was it started where the teeny stuff, fine, everything I'd ever created in my life, not counting movies or sounds, could easily go. And then it started to encompass finally the last round of them. I could throw all my movies of my kid walking and that sort of thing. But here's the point. a lot of data in business, people talk about big data. A lot of data is not that big. I mean, if you're a company and you've got 1,000 customers, which is like a lot of customers for a lot of companies, and you've got, information about each of them, you've got 1,000 bytes about each of them, 1,000 times that's only a megabyte. You can have 1,000,000 times more than that, and that's only a terabyte. Like, that's not even one disk drive anymore.
Right.
Data is mostly not that big. Right? And then you have these few examples that really are enormous. And I just think that what we'll start to realize is that a lot of corporate data, even data they call big data, there's exceptions, but a lot of it's just not that big. So keep it in flash, keep it in memory, keep it right in the main, when you look at SAP HANA, just keep it in the main memory of the computer. The whole thing can fit. And the problem is no longer, how do I get access to all of that data? The problem, how do I make sure it's backed up? How do I move it around? How do I keep track of which countries I let it go into? Because the laws, right? That's a lot of what we're looking now is those data management issues. And then that big pile of data that's piling up, that's a separate category.
So intelligent data placement, dealing with the heterogeneous storage environments, right? Different tiers. It's starting to sound like artificial intelligence is needed to start fixing some of this problem. Let's go down that path. What are you guys seeing on AI? Where do you think it's going to take us?
AI, we think thinking machines, but right now AI is pretty much, we've told them what to do. They're not quite learning and developing all on their own, but that's sort of assimilating like they're really thinking. Like I can talk to Siri and ask a question and get an answer. It's still not there where it thinks up its own solutions, its own solution methods, but it's so much helpful. Everything that kind of thinks out my life. Look at Google now. I hate to use Google as an example, but Google now thinks out what I might be interested in and need at this moment, and it really helps me through life. So I think that's good that the machines start thinking more and more. Which format should I have the data in? Where should I place it? When should I move it? And do this for me. That's really good. But it takes an awful lot of work on the part of the IT companies like Primary Data to make this a reality, to simplify the lives of the users and give them better performance. But they don't see how much work it takes in. It doesn't just come simply.
Yeah, what we do know is if we do put the data in the right place at the right time, we're going to get higher throughput, number of higher transactions per second, meeting those mission-critical applications for sure. Dave, we've been talking about AI, on the side before we got started, and there's these 10-year trends. Sorry to interrupt you, but there's this 10-year trend that you have talked about many times, like technologies that are occurring today. Is it enduring? Does it last? Will it transform into some other use case for us?
I'm interested in trends that last a long time. Like, the PC is introduced, the Apple II, late 70s, IBM PC, early 80s, and it takes 10 or 20 years before you can just assume everybody's got one on their desk. I mean, that is a long trend. To me right now in AI, one of the most interesting trends is, if you look at AI historically, AI was way better at things that 40-year-olds could do. AI could play chess. AI could solve traveling salesman problem. AI could do all of this amazing stuff. Did people see the headline, a computer finally beat a Go master? Go has been like the last game to fall. What's happening now, and this is the amazing thing, is AI is actually getting to be good at things that 4-year-olds can do. Right, so before it was things 40-year-olds can do, chess, here's what a 4-year-old can do. A 4-year-old can understand you talking. A 4-year-old can tell the difference between a cat and a dog. A 4-year-old can kind of sort of drive a car. I mean, not on the road, thank you, but, and these are things that computers just couldn't do at all. And they're starting to. And I think that's going to be the place where we suddenly start seeing computers we've had computers in our world for a long, long time at this point, but they've never been in our world the way 4-year-olds are, wandering around, interacting with us, talking to us, making those kinds of decisions. That, I think, is going to be a radical transition as we start getting, because first it'll be 4 and 5 and 6 and then remember when they get to 40, they've been better at us at those things forever. So that's the next 10 years, I think, of we are going to start to see them moving into the normal zone of thinking.
We're not writing more instructions to the computers to how you can be more intelligent. Think about this, think about that. We aren't necessarily doing that. Sometimes we're just giving them a better method. Why don't you play a game against yourself a lot of times and learn what works? Sit down there. They have the machines that hook into the old video games and sit there just knowing I have to try to get a higher score and within an hour they can beat any human.
So you're all
So you're
irrelevant.
Gone. You're
Woz, is there any caution or is there anything danger in this path that we're going down with AI?
Oh, a lot of people see a danger because, oh my gosh, look at the robots that replaced all the jobs in car factories, and now we might be replacing the thinking jobs, the people that run companies, because robots can do it better. But you know what? Every time we take another step, we find out that the robots are really just helping us, and we wind up doing everything else. And I think that a world where you could imagine, oh, the robots, the humans aren't needed anymore, is actually so far off. So many hundreds of years, we don't even have to think about it now. We may not even be around then. They're just going to be helpers to human beings. They're going to be friends to us, and I hope they come up knowing that we're not, because we're different, we're not a different group and a species to fight and segregate and be worried about and be separate from. I think they're always going to be linked with.
Woz, I think you just brought a whole new meaning to the words making friends.
Good try.
Do we fight the robots or do they help us?
I am not afraid of artificial intelligence. I am afraid of artificial emotions. And here's why I say that. Anybody remember Star Trek? You know, there was that Spock guy. Spock is never putting together a plan to conquer the world. Like, he doesn't care. He's just like, well, that's interesting. That's curious. That's, you know, I don't think you start getting the real, like, trying to go fight people, kill people, until you get artificial emotions. When you start to get robots, never mind thinking good thoughts, when you start to get them to be afraid or aggressive or greedy, that's when all hell will break loose.
Well, now, Isaac Asimov said, a robot can never harm a human being. Kind of a moral statement.
First rule, right?
And he had it all wrong. He had it so wrong. If a robot is truly intelligent, it's not following our orders not to harm a human being. So that still hasn't reached its own intelligence level. It's artificial maybe, but it's not real intelligence. Now, Woz's law is a human being can never harm a robot that is thinking, that has emotions, that has feelings. We should never make them feel that we are going to be a threat to them. Start their culture out good, and they'll always be helpful to us.
Don't scare the robots.
But we're so far from that. We're not at that point. Our artificial intelligence is still a little bit phony.
So you've got us
who
way up
knows?
here. I want to bring us back to innovation, and I want to tell a story. I was part of a team that invented a new cocktail. And the cocktail is called a Dr. Death. And I want to tell you the story of the invention of this cocktail because it actually, to me, it sheds light on the nature of innovation. So I was on a plane, and I'm sitting in the aisle seat, and a woman named Laura was sitting in the window seat next to me. And the flight attendant came out, and she said, would you like something to drink? And Laura wanted a sea breeze, which is, anybody know? Half vodka, half cranberry. And I wanted Dr. Pepper, because that's the best soft drink. And so she says, would you like anything to drink? And Laura says cranberry, and I say Dr. Pepper, and Laura says vodka. And here's where the magic happened. The flight attendant turned her head side, you know, that puppy look, and she said, cranberry, Dr. Pepper, and vodka? Really? And that is what a Dr. Death is, by the way. It's an awesome drink. It's kind of like a Long Island iced tea. You can't really taste the alcohol because the sourness of the cranberry cuts it, and then the sweetness of the Dr. Pepper. And it's called a Dr. Death because, holy shit, the next morning. We had a bunch of them. But here's the thing. So the flight attendant goes, cranberry, Dr. Pepper, and vodka. And Laura, she gets this look in her eyes, and she goes, oh my God, yes, I want that. And then I said, yes, and so here's the question. Who invented that drink? Right, me and Laura were just talking over each other. The flight attendant misheard it. She's the first person who ever said it. I think it's either the flight attendant who invented it, or possibly it's Laura, because she was the person that said, I want to drink that. And then I was the fall, and
or nobody really invented it, but somebody gets the credit.
But why am I telling this story? I think the nature of invention is not that sometimes there's one smart guy working away. I don't want to say that never happens, but a lot of times the nature of innovation and invention is you get people mixing it up You invented the circuits and you did the programming, but you could argue that a lot of the innovation was the first people who started using this thing and going, oh my God, I could do VisiCalc, or, right? The innovation is more pieces than just any one part of it.
Yeah,
And
look-
then
well,
you
look at
fight
an
about who
iPhone.
gets credit. That doesn't make sense. It's
Look at
accidents.
an iPhone. Really, the third-party app store changes my life more than anything. It's when all the hundreds of thousands of people that are smart out there start putting their own applications onto it. And what is an iPhone? It's not just one thing. When you have a platform, it's a lot of things. But all these inventions kind of come about by accident, and that's what I sort of think about a lot of the things we've gotten in technology. For example, we're talking artificial intelligence a bit, computers doing things that the human mind does, and we're getting closer to understanding how do neurons maybe work, and how does the brain maybe work. We're trying to follow that, but have we replaced the human mind yet? Well, one example we have in some ways. You used to ask a very smart person with a big brain a difficult question about the world. And now who do you ask? It starts with G-O, and it's not God. So did we ever invent computers, internet, all this stuff thinking this is the path we're going to build a brain, or we're going to replace a lot of the brains in the world? No, we just kept trying to extend technology in ways that we thought would be useful, and we wound up with tons of people were finally publishing, and we had to have search engines, and it replaced a lot of brain work. Now it's there, so why do you have to learn all this stuff, about the tallest mountain in Florida?
Fifth graders do that so they can go on a TV show and win some money.
That's the reason.
Actually, I want to make one comment, Dave. I think what was interesting about your story is that normally this would be this cycle of, inventor, talk to a customer, listen, and go through this cycle. You're short-circuited. The customer asked for something and immediately got it without an inventor thinking about, hey, should I try and test out these various different combinations? And I think it's a very good story of how to actually get to that solution quickly and what the customer wants.
I collect innovation stories.
Very nice.
I didn't know if he was talking about the Dr. Death.
I am.
So here's another one. There's the product manager and the engineer at a wallpaper company. And the product manager says to the engineer, I have got this great idea for a product. It's wallpaper, but you know how wallpaper usually you put it up and it gets wrinkles in it and it goes in the wrong place and it just sticks? This wallpaper will be like magic. You just put it near the spot you want, it aligns perfectly to the side, no wrinkles, it just sticks right on, and customers will love it. And the engineer says, oh my God, that sounds awesome. How does it work? And the product manager says to the engineer, that's where you come in.
So there is a lot of technology out there that can be overhyped. Give us your thoughts on what you think is unrealistic, and also on the reverse side, on the other side of the coin, what is the most interesting thing that you're seeing today?
I don't know. I see technologies all the time, and I say this is unrealistic. It's not going to go, and some of them do go. so it's very hard to say because almost anything we think of is somehow possible with technology. Flying cars or self-driving cars and artificial intelligence. So who knows where it goes? It's just yeah. I'm not going to say I think there's a bunch of technologies out there that have no future and they're going to.
What's the most interesting then?
They are. Most interesting things are what we've been talking about. A lot of the artificial intelligence applied to devices, machines that kind of look out and act like a human being, make decisions that a human being would make, whether it's in the data storage area like primary data or self-driving cars or whatever. And I mean, some of that's not very surprising, actually. I think everybody buys into a lot of it. Virtual reality is going to be, I think, a big hit too. But you never know. It's emotional, and maybe it'll come quick and die, and maybe it'll be stick with us forever. That's what I would predict.
What do you think?
I think that cloud computing is the most amazing, interesting trend going on in IT. Artificial intelligence, I'm way there with you. I think that's a little further out. But what's going on with cloud computing is just so radically changing the way people think about so many things. And to me, it is a bigger trend when I look at all of the previous transitions of computer technology, mainframe to mini to Unix, micros to PCs, like all of those trends, in the end, you still said, I'm going to buy a box. Where should I put the box? Who's going to run the box? How much power for the box? What software on the box, right? It was always like that. Now you look at cloud computing, and people are saying, well, maybe should I buy a box and run VMware myself, or should it live in the cloud? Maybe I don't want any IT myself. Like, it is a radical change, and I think it goes way beyond any of those other transitions, that whole idea of figuring out where in the world the computing should be happening and how you interact with that. I don't think cloud's going to replace all of the on-prem stuff, but at the same time, I think it is just the single biggest thing going on in IT now, and we are going to be many years figuring out what that means and what to do with it and how it plays out in the end.
I think a lot of people come to the same conclusions about the cloud, but it takes me back, and I remember we kind of started Apple Computer in its founding days to get out away from the cloud, the cloud of the day. The mainframe that was shared by a lot of people. Yeah.
So I have a theory about why it is that we moved back to the cloud, because in the old days there were mainframe computers, right? And you logged in with your. Did anybody have one of those like 400 baud things? Old people. And then 19,200 baud, you know, the ADM, the Lear-Siegler terminals. So the thing that forced the computer to go right near your face was the bandwidth of your optic nerve. And here's what I mean by that. If you're sitting here and the computer is a long ways away and you want to have interactive graphics and see things and move and, you know, virtual reality and all of those kinds of things, we just didn't have the bandwidth back there to feed your optic nerve. And so we had to bring the computer right close to your face, right? And so bringing the chip close, bringing the graphics processor close, all of that was about getting the computer close enough to your face that you could see real data intense, graphically intense stuff. But now, bandwidth is getting so big that we actually can move the compute back out into the cloud. And all we need in front of our face is just enough compute to do the rendering, the final putting it up there. And so I don't think we'll be coming back again, because now that the bandwidth is there to saturate my optic nerve, I mean, once you've saturated my optic nerve, what else is there to do? So the cloud's fine.
Almost everything we have in technology that is somehow better the direction that we're moving in, it's almost all starts down at the atomic level. And bandwidth of the internet really is what spurred this move to the cloud. It wasn't that we said, oh my gosh, we want to go to the cloud. It's as the bandwidth increased for even other reasons, now the cloud works. Now there are other solutions that are possible. And the right ones are obvious.
So to conclude, what you've just told me is that we've gone full circle. We went from centralized to distributed, back to centralized again.
Yes. But it's not the same centralized it was, but yes.
Fantastic. Well, I think that's all the time that we have today. I'd like to thank both Dave and the Woz. I'd also like to thank Trace3 in putting this event together and talk about innovation. And just to let you know, smartest people on the planet, they think about your problems, how it evolves for you, and how we can solve those problems. I want to thank you, gentlemen. Appreciate everyone's time. Thank you, everyone.
Thanks.
Thank you, guys.